Hi there, it's Ian McTavish with Hoya Robotics, and this is our tutorial on communicating with the robot with programming. And our sponsors allow us to do all of the work that we do, so we extend our extreme appreciation to them. So we have a few tutorials that we've already used, so the code that we already have in place was built using those tutorials, so that's where you can access them. Now, communicating with the robot, we're going to focus in three separate areas, through the console, through Shuffleboard, Smart Dashboard, and through file logging. So we'll start off with the console. With programming in Java, Hello World is kind of your first program that most people start with. And the idea is that by having the words Hello World on there, it's showing that the robot or the computer is communicating with you. There's a long tradition with that, but you can Google that information. So that's kind of the idea. We're going to use the console because system out print line will work in VS Code, and it'll allow, in our driver station, we can actually see what the output when we use system out print line. So it's a quick and easy way, if you've already programmed in Java, to be able to communicate. So for example, I'm going to open up my code here, and in the robot container, so this is the robot container program, and I'm just going to go down here. I'm trying to find my code. So here's my constructor, system.out.println. And this is a really good troubleshooting. So system out println, it's got brackets. Keep in mind println. If you're new to Java programming, that's not a 1, that is an L. And then what you have in brackets is your string, so you put it in quotation marks and you put what it is. So this will run, and I'm going to deploy my code to the robot, and what I should see is I should see that line of code in there. And it's starting up. The other thing that's really useful, this is really good troubleshooting and learning when different methods actually get called. So if you put in print lines, you can actually see this gets called at this point, this gets called before then, and sometimes something doesn't get called. So it's a good way to see when things happen if you're not 100% comfortable with how it's programmed. So there it's deployed, and it should pop up and in the constructor for the robot. And in here, I should be able to click on the little asterisks, and I should be able to see all of the comments. And there, the screen's moving, so it's a little hard to see, but in the green, in the constructor for robot container. So I can see when things are called, and this can be really useful because I can clear this, and you can see. So this code is actually called when it's deployed to the robot. So that's really useful to know. So there's certain things that happen when the robot is being deployed to. So in your driver station, this little box here with the little gear, you can view the console and you can see all of that kind of information. So it's really, really useful, and it's a great way to troubleshoot so that you can see when things are happening. So that's the first part, and that's it. Now, if you've programmed in Java, you know there's different data types. There's strings, numbers. System out print line works just the way a regular Java program would run. So I always encourage students to look at W3 Schools to see how it's structured. So the Smart Dashboard to Shuffleboard, this is another way to communicate. And one thing that is really useful is programming is being able to determine autonomous. So for example, and this slideshow is there, but I'm just going to explain. Here we are, and this is our robot 4152 in the first Steamworks game. And you can see where there's the left, there's the center, there's the right. So maybe you have an autonomous program that runs differently depending on the position of the robot. And this is a really good way to be able to select which position you're in and be able to select the code that is going to run based on that. So we're using command-based programming, and the WPI library is a really good resource. It explains how the command-based programming works, but basically break it down. You have subsystems, so your drivetrain is a subsystem, and then you have commands. So you may have a drive with joystick, which will use the drivetrain to drive based on the joystick. You may have a drive based on time, those kinds of commands. So we're going to use that, and what we're going to do is there's 3 files. The subsystem we're going to create, it's going to be called Autonomous Picker, and the goal is to send choices to the dashboard for that. And we're going to create a command which will have our autonomous, so it's going to have a run autonomous method which will pick which autonomous method and run it based on that. And then our robot container is going to call that method. So that's the game plan for how we're going to do that. Now, in here, I'm going to start by creating a new subsystem. So I right-click the subsystems and select Create a New Class command. And in here, I can start typing subsystem. So there's subsystem new. So I'm going to hit enter on that. And then I can pick the name. And for this, it's going to be Autonomous Picker. So that's going to be the subsystem. You want to have a descriptive name that starts with the capital letter. And I'm just going to close up this so that I can see everything a little bit better. So here's my Autonomous Picker subsystem. And what I'm going to do is I'm going to create, now you'll notice line 12, right after line 12, I'm going to go into line 13. So this is where I'm going to create my variables. And the first one is going to be an enumeration. So enum is short for enumeration. And basically this allows me to create numbers and use names instead of numbers. So there's my squiggly braces, and my strategy is create the opening and closing, use the arrow key to go back, and then hit enter, and I'm indenting so it's nice and clear. So I'm going to have 3 starting positions: left, center, right. Okay, so you'll notice I'm using all capital letters. It's a comma separated list, and that allows me to, so this enumeration is actually going to assign left the value of 0 because it's the first one, then center is 1, then right is 2. And it just allows me to use these numbers instead of kind of going, okay, what was position 0 again? Oh, it's the left. It allows me to use names instead of numbers. So that's my first thing. Then I'm going to create my variables, and I'm going to need 2 different variables here. So the first one is the starting position, is based on my enumeration. And the tradition that we use on our team is classes and enumeration data types are given capital letters, and then variables that represent those start with the small letter. So my starting position initially is null, just so that it's set to something. Now my next one is called a sendable chooser. So a sendable chooser, and you'll notice that there's a little less than starting position. So sendable chooser is a type of data. You can see what it is, and the less than and greater than sign, this is the type of values that it's going to store. So it's going to store my starting position. Okay, so that's, and I'm going to call this my start position chooser. So there we go. I've got that's my variables set up. So in my autonomous picker, this is my constructor. I'm going to take advantage of the system out print line. So as I'm learning how this works, I can see when things happen. So start position chooser, I've got to create a new instance of it. So new sendable chooser, and you'll notice that it's got the less than and greater. That's great. And what I need to do now is I need to start position chooser, and I'm going to set a default option. So the name is, this is a key value pair. So the name is what it will look up, and then the value is going to be this, and there we go. So my default option is going left. Start position chooser, I'm going to add another option, and for this one it's going to be center. And because it's an enumeration, there's my different values that show up, and my last one is going to be the value of right. Now this demonstration is just based on the position, but you could have all kinds of different autonomous routines. My key thing is keep it simple. You want to test everything and make sure everything works, so that it's working perfectly. So all my options are added. The last thing that I need to do is I need to go to the Smart Dashboard, and I need to put my data into the Smart Dashboard. So I'm going to call it starting position because that makes sense. Would help if I could spell it. And the data that I'm sending is start position chooser. Now I've got a bit of an error here. And I got to put a comma in here. That should solve it. Okay, so I've got everything in there. In my slideshow, I add another print line, but in the sake of brevity, I'm going to skip that. Let's just try compiling our code and see if that clears up our problem. It's not getting it. Okay, I'm having a bit of an issue here, so let's just try that again. Put data, there we go. I just needed to select the right thing. So that's okay. Now I just need to remember what I typed. Starting position, and it's going to be the sendable chooser. Start position chooser. Okay, so I've got that set up. That's good to go. Now I'm going to add a new method here. So going down, there's different methods. So it's hard to remember when this happens, but basically remember that the squiggly braces line up so you can quickly see. So what I'm going to do is after autonomous picker, there's my closing squiggly brace for that. So if I do enter, I should be able to type my new method. So I'm going to create a public method, and public is because I'm going to be able to access it from other classes. And I'm going to call it get my autonomous. So it gets the autonomous in my position in my end. So because I'm returning the starting position, I've got to return that position. So this is going to get the selected one, whatever the person selected in the dashboard. So that allows me to do this. So that's really, really helpful. So I've got that in place. Now I'm going to add a command. So over in the commands, create new class command, and just start typing command to find the option. There's the command, and this one is going to be called autonomous. So here's my command, and in my autonomous, so there's where the class is created. So I'm going to create a private final autonomous picker. So the very subsystem that I just created, I'm going to create a variable based on that, and I'm going to need to access the drive base as well. Okay, so I'm ready to go, and down here, public autonomous. So I'm going to take an autonomous picker, and I'm going to take a drive base as, so these are parameters that I'm going to pass when I create this, and I am going to assign them. So this autonomous picker refers to the one I just created on line 15, and if I just use the name autonomous picker, that refers to the parameter of line 20. So same thing for the drive base. So I've now declared and initialized those values, and I'm going to use this add requirements. So add requirements, and autonomous picker is what I'm going to require. I'm going to require that subsystem. So there we go. And what I'm going to do is I'm going to create a method. Same thing, I'm just going to go through. Now I'm going to put it after the execute method here, because logically it makes sense to put it there. So it's going to return a command, and I'm going to call it run autonomous. So this is going to return a command that I will then use. So what I'm going to do is I'm going to create a sequential command group. So these are my auto commands. And the reason I'm doing a sequential command group is I want to have a series of steps. Initially, it's not going to be very much, but the whole point is to test this out. So I'm going to use a switch statement here. And a switch statement, if you're new to programming, is where you can switch what you do based on what you get entered. So here I'm going to get my autonomous value, and I'm going to switch the code based on what value I get. So I open and close my switch statement, and I use case. So my first case is left. So if the person enters left for their autonomous picker, then what's going to happen, system.out line, out.print line. This is just troubleshooting, so I can make sure that I know what's going on. And I'm going to create auto commands. I'm going to set that to. Now, you may notice that I'm adding a second set in here, which seems kind of silly. But my goal in here is to just have this ready so that I can add other commands later on. So this is going to be new drive for time, and pass the drive base, And basically I'm going to go for 0.6 speed, so 60% speed for 2 seconds. This is different from what's in the thing. That's okay. So you'll notice that there's no semicolon because this command group, it's going to take a comma separated list. So each command, I'll have the command, the comma, the next command, etc., etc. Right now I'm only putting in one command, and that's just so that I've got it in there and I'm ready to add more commands later. Then I'm going to have a break, and then what I'm going to do is add other cases. Now for now, I'm going to skip adding other cases, and I'm just going to simply add a default. Oops. So the default, if it's not left, it's going to run the default command. And auto commands and group, and in here I'm going to put new drive for time, drive base, and what I'm going to do is I'm going to set it to 0. So we're not going any speed for any seconds at all, just so that way there's no issue. And after that, I'm going to break. So right now I've got the left option and a default option. And after my switch statement, so just comments are really helpful as you're going along. So after this, now I'm going to return my auto commands. There we go. So that's what's going to happen. And there's a command can't. So you'll notice that I'm using, so hold my mouse when there's the error. It says there's a quick fix, and the quick fix is to import the command library. So there we go. So there are some times where you need to do that. So perfect. Last part is my robot container. Everything happens in my robot container. And so what I'm going to do is up at the top, here's my variables. I've got my driver, my drive base, and I'm going to create a autonomous picker. Okay, so I'm creating that, and I'm also going to create my autonomous. And with my autonomous, I need to pass my autonomous picker and drivetrain, and this is why I use the same name, because it fills it in for me. So all is good, and that's great. So down at the bottom, here's my autonomous. This is what we created the other day, and all I'm going to do now is remove this. So I'm going to call my autonomous, run the autonomous, which returns the command, and that's what's going to do all my autonomous. That way, this code in Robot Container is very short. It's easy to troubleshoot. Everything autonomous is in the autonomous page. Okay, so let's try building this to begin with. Building code worked, I believe. Now, I'm going to test this, and really, really important is you want to make sure that your robot is off the floor so that you can test it. And that's really important. So I'm going to deploy it. Now, once it's deployed, so build successful, all is good. Here's my FRC driver station. Over here, you'll see the little cog here, the setup, so I can select what type of dashboard, and I'm going to pick the shuffleboard. And I really like the shuffleboard. I've already got it set up because it brings up shuffleboards like this. And I am going to deploy my program in autonomous mode. And you couldn't hear, but my robot was running away there. And here's the shuffleboard. So you can see there's the starting position. Now I've already got this set up. You'll notice that little arrow, I can go through here and I can find the different options. So I'm going to just create a new tab here. So here's a new tab that I can use, and starting position, I'm going to show it as a split button chooser. So here it is. Now I better resize it. So right now I've got it as right, and what happens is that if I run this, my autonomous doesn't run because the default program is running when it's right. If I select left, go back to the dashboard, I'm just going to hide that. Now that I've got left, you can't probably hear that, but my rotor motor ran. One thing that I mentioned, I said you lift the motor up, or the robot up, so it's not touching. If you put it on a cart with wheels, you can actually test your autonomous if it's dealing with gyros and stuff, physically move the cart and see how it reacts. So that's handy, that works. A couple other things that I just want to mention with regards to this. Number one, I'm just going to go back into my drive with joystick. And the reason is I'm going to show you under execute, my smart dashboard is really handy because I can put numbers in there. And what I'm going to do is I'm just going to put the throttle and I'm just going to set that up, get it as a double value, and deploy that code. And the bonus is this will now be available in the dashboard. I have to run my program first once so that it will find that code. So I'm just going to enable, whoops. And now that I've run it, I should be able to find that particular piece of information. I might need to run it in teleop. And there's my throttle. Now, the nice thing is that you can show this information in a variety of different ways. So there's my throttle. I can move things around, I can resize them. And I don't have my joystick plugged in, so it won't be very exciting, but this value will change based on my joystick reading and stuff. So it's really easy to put data in there, and it's really easy to put it in a graphical manner, which is so handy because it just makes it a little bit more visually. If you're looking at a whole bunch of decimal numbers, if you can just have it on a scale from 0 to 1, you can change the scale. All of these things are really useful to make it worthwhile. So the shuffleboard is a very handy tool. Once you've got it the way you want it for competition, save the layout, and then you can make sure that You can load the layout for testing. We can record our values. It's really, really handy. And if you look through the slideshow, there is information on how to access the WPI library documentation, which can be very useful for this. So we're just going to skip a whole bunch of slides right now. So let's get down. Yeah, so there's the link. Really useful. There's a lot of options in here. Take advantage of it. Okay, file logging. So this is our robot from 2020, Excalibur, and for this season, we performed 1,000 test shots. This is our setup in the Huntsville Place Mall, and we would set up the robot, we would shoot, and we would record all kinds of data. And basically, you can see this shot is going low, so we've drawn a grid so we could easily record where it actually landed, and we would have a log file where we would track all of this information, and that allowed us to determine, we could pull it into Excel, graph it, and we were able to figure out what formula would work for different distances to be able to calculate it. So this is our file for it. And you can see there's a lot to this. I'm just going to access the raw code. And so this is called logger, and I'm just going to copy that code. And I am going to okay, so in my source, I'm going to create a new folder called util. I'm not going to do it there, I'm going to do it here. Oops, no, it's already there. Cool. Okay. Okay, so here's my logger file, and the bonus is that I can just copy and paste that because I'm using the same names and everything. So that's really, really handy. And here's the shooter method. So in the shooter method, you can see Control F logger. You can see there's a whole bunch of times where we use it. So logger.info as its most basic. So I'm just going to do this for my new autonomous picker. And info, and you can see we've got the different options here. Selected, and that's going to refer it to a string. So there we go. So let's deploy that robot code. And I got a couple of errors here. That's not a problem. Let's figure out what the errors are. So all files are not saved. So let's start by saving this particular file. And let's start by building the code. I'm wondering if the okay. I'm wondering if it's, I didn't save the logger, so let's, now that I've closed it, it should It's failing faster, so that's a good thing. Okay, so here's my Java error line 145 in Logger. Okay, so let's go to line 145 and figure out what's going on here. I think I accidentally deleted something. So let's save that, Control S to save, and learn the short codes so that you can build stuff really fast. There we go, build successful, deploy it to the robot. Now, the beauty is I can put a memory stick into the robot and my log file will then get executed. So I'm going to now run my robot right now. Open up that shuffleboard again. And what I should be able to see is I should be able to view my log files. And if I pop my memory stick out, I should have a log file that I've created. So these are the default log files that come, but my new one is really, really useful because then everything special that I want to put in there, I can. If I set things up as a comma separated file, I can easily pull it into Excel and easily graph it. So those are some of the skills that are really, really useful. Take advantage of them. And thank you so much for listening to my presentation.